Okay, so for the very last example in 11.5 and for the remainder of this school year, we're still using the limit process to find the area of, underneath the curve of this parabola over here, of this function, on the interval from 0 to 4. And again, we're asked to use the limit process, okay? So this problem's already been done for you, and I'm just gonna kind of walk you through the steps, okay? So what is what's the picture of the graph look like, right? This is your, if you remember, right, this is just vertex form. It's 2 comma 4, shifted 4 to the right from, x squared. And your graph would look something like this. You're being asked to find the area underneath this curve, right? So this one, you can't really use any formula. It's like, oh, let me maybe try to draw rectangles. But remember, you're taking the number of rectangles that you draw, you get a better approximation if you increase the number of rectangles like towards infinity, right? So you can't just say, oh, I'm going to draw 4 rectangles and I'll be done with the problem. So you have to use the limit process. All right, so just like I did in the previous example, right, to figure out the width, right, you do b minus a over n, so 4 minus 0 over n. And we don't know the number of rectangles because we're going to take the limit. So we'll say 4 over n. And then the height, right, is f of a plus b minus a over n with the counter. Okay, so you're going to plug this into the function here. So you're going to plug in f of 4 over ni into this function. So when you plug in 4 over ni, right, you're going to get 4 minus 4 over ni minus 2 quantity squared. So you can see that the algebra on this problem is going to get really messy. And so if your algebra skills are weak, if you make a mistake here or there, your final answer is going to be really messed up. Okay, so just be careful as you do these problems. Take your time with it, and just be careful with your minus signs and whatnot. Okay, so hopefully you know where I got this from, right? This is the height of a single rectangle. And how did I get this? I plugged this into this function, right? 0 plus 4 over ni is just 4 over ni, okay? All right, now I actually FOIL this, right? So if I FOIL it, right, you square the first term, you're going to get 16n squared I squared, this term times 2, you're going to get 16ni, right? And then you square the last term. So if you had trouble squaring, basic, x minus 2 squared, right? Squaring something like this, it's very easy to make a mistake, okay? So again, this is just FOILing. And then the next step, I just basically simplified it, down to this, right? Because if you distribute the negative 4, it simplifies to this. All right, so I got the width, I got the height, and I need to plug it into the limit area formula. Okay, so my limit area formula is going to be this. And you're going to take the limit as n goes to infinity of this particular function. And it looks like I didn't write the limit as n goes to infinity on each line, so I expect you guys to do that. I'll write it in as we go along. All right, so I'm just going to remove this right here. You can kind of see the algebra of what happened. I'm going to write limit as n goes to infinity on each one of these problems because I expect you guys to do so as well. Okay, so again, remember to start this problem, right, you could factor out the 4 over n and then just take the sum of each individual term, right, by splitting it up. After you factor out the 4 over n, right, for this particular term, you can factor out the negative 16 over n squared, or I wouldn't say it's factor it out, it's just move it out, right, because now you can see the I squared, and you have a formula for the I squared. And you can move the 16 over n out on this one right here, and you have a formula for the I, right? So these ones right here, you can actually substitute the formula for the I squared one. Again, I don't have it memorized, so I would just look it up, right? It's n times n plus 1 over 2n plus 1 over 6. And then for the I one, it's just n times n plus 1 over 2. And then, as I always like to say, right, the rest is all algebra. You can see my simplifying, work over here, right? 16 and 6 reduces to 8 over 3, right? And over here, I cancel this out from 16 over 2 to 8. Okay, these ends are going to cancel out. These ends will cancel out. And as you move along over here, right, just keep canceling and simplifying. And I went down to this line right here. You can see that I didn't actually simplify it down to a single rational expression. It's okay if you have individual terms like this. And then just take the limit as n goes to infinity, again, I actually distribute the 4 over n in case you're wondering how I got from this line to this line. I distribute the 4 over n. You could take the limit of each individual term, right? The limit as n goes to infinity of a constant is just the constant itself. 32 over a large number is just 0, right? 32 again over a large number is 0 plus 32, and then plus 0. Your final answer after all that work is going to be 32 over 3. All right, so you can kind of pause this video and see which line did you make a mistake. And I mean, the concept is fairly straightforward, right? Calculating the width and the height of a rectangle, and then it's the algebra part that might trip up students. And I always like to say that, right? I know some of you want to enroll in calculus someday or maybe next year. If your algebra skills are not strong enough, then it's going to be really, really difficult for you to succeed in calculus.